we are looking at 52 today. It is our in-class graded assignment. Basically, it is covering our similar figures and Pythagorean theorem. So I think you guys are going to do pretty good with this, but I did want to help you and set up some problems with you. So in the first one, we're talking about indirect measurement, and we're going to use proportions to help us with that. So I'm going to probably cut off a little bit there. Okay, so it says a tree casts a shadow that's 17 feet long. So the shadow is 17 feet long, and the mailbox casts a shadow that's 4 feet long. The mailbox is 3 feet high. How tall is the tree? And to get full credit, you're going to draw a diagram. So you don't have to draw a tree, but the big thing is you need to show we're looking for the height, and there's a shadow that's 17 feet long. This is what's going to help you. So do you have to draw the picture of the tree? No, but height of tree, shadow. Now, I have a mailbox. All right, so the mailbox is 3 feet high. That's the height of the mailbox. And the shadow is 4 feet long. So the idea is the shadow is longer than the mailbox is tall. So when I go to do this, I could do height to shadow equals height to shadow, or I could do height to height. I think I'll stick with that because that's what we've been doing, is the height to the height equals the shadow to the shadow, but you have to be consistent. If you really look at these, do you guys see that you have triangles here? You would have similar triangles because when we're doing the height, you're talking about 90-degree angle and altitude, and the sun is going to cast the same angle shadow at a certain time. Okay, now, you would cross multiply, you would find your answer, and make sure you label it, okay? I know you want to ignore me and finish that, but I promise you we'll be quick and you can go back and finish these things. So, next one talks about a photograph. So here's my little photograph, and we're comparing it to a poster. So I've started your sketch for you. Make sure that you label this properly so you can set up your proportions. Okay, look at number 3. We have two quadrilaterals, and we're trying to determine, are they similar? Okay, in order to prove that these quadrilaterals are similar, I need to prove that the sides are proportional. Now, I wish they would tell us, but I'm going to say the angles are corresponding. Okay, so these angles correspond. What we're doing is the sides. Now, it looks like these are in the same form. Like I haven't twisted it, flipped it. So what I'm going to do, though, is I'm going to look at the sides. These two are the same, and they're the shortest. So 3 goes over 3.75, and this top 3 goes over this top 3.75. Now, the longest side on both figures are right here. So that would be 5 over 6.25. And then that base is sort of in the middle, 4 over 5. So do you see that I was consistent? The tops are all from the left, the bottoms are all from the right, they pair up. What do I need to prove that these are similar? I need to prove that these truly are equal. So take 3 divided by 3.75 in your calculator and see what you get out. Are the decimals equal to each other? If they're all equal, yes. If they're not equal, no. So what is 3 divided by 3.75? What is it? 0.8? All right, so we know these are both 0.8. What's 5 divided by 6.25? That is also 0.8. So we have one more to check, and I believe that is also 0.8. So since all these decimals are the same, yes, they are similar. Now, if you were asked to write a similarity statement, you would write out the quadrilateral ABCD with your similar to quadrilateral WXYZ. And again, the other thing is we knew that the side AB went with the side WX, okay, the way they were listed. Okay, look at this one. Again, I'm not going to do the whole thing. It says the triangles below are similar. So we know they're similar. What's the measure of y? So we're actually not finding the side, we're just finding y. Guys, look at my triangles. Do you see the matching angles of 42 and the 90? Why are these triangles similar? Angle, angle similarity. Now, what goes with what? Well, the side off the 90, y plus 3, goes with this side off of 90. So you can see this has been reflected over. And then I'm going to come back and do my 12 over 9. Now, what I set this up for you is I wanted to remind you, when you cross multiply, it's 9 times y plus 3. So you have to take 9 times y and 9 times 3. Okay, as much as you want to ignore me and do this, please jump to the back so you have this information. In number 5, it also asks, are the polygons similar, why or why not? Guys, for numbers 5 and 6, there are 2 things we need to check for similar polygons. The first thing we need to check, are corresponding angles congruent? Are corresponding angles congruent? Okay, well, let's look at this. We have the 2 marks here and we have the 1 mark here. So yes, number 1 is a check mark. Corresponding angles are congruent. Look down here, 2 to 2, 1 and 1. This is flipped over. Corresponding angles are congruent. So that's one idea. The second idea we're looking for, are corresponding sides proportional? Those are the ways that we prove corresponding sides proportional. And that's what we just did on the other problem. So you're going to go through and set up 9 over 6. Does that equal 13.5 over 9? You're going to set up these corresponding sides, but you have to make sure they match. Same thing down here. So you're going to do exactly what we did in number 3 to prove it. Okay, now look at number 7. It says a 6.5 foot tall car, and this is what bothers me. Standing next to an adult elephant casts a shadow 33.2 feet. Okay, guys, the car is 6.5 feet tall, and the car casts a shadow. It's just saying it's next to an elephant. The elephant has nothing to do with this. So draw a car. I'm drawing a boxy van, and that is 6.5 feet high, and its shadow is 33.2 feet long. Now, it's sitting beside an elephant. Well, I'm not very good at drawing an elephant, and some people make fun of my elephant. There's my elephant with his big floppy ear. There's my elephant. There's his little stick legs and his little tail. Okay, done. We're trying to find out how tall the elephant is. If it has a shadow, it's 51.5 feet long. So do you see that we're doing the same type of indirect measurement? You're going to do proportion, height to height, shadow to shadow. Make sure you solve it and label it. It's the best elephant I've got. This looks more like a little buggy drawn, you know, the back of those little buggies. No, do you see the wheels down there? And the windshield? Well, anyway, you can draw a better picture than me.
Mine has 2 wheels. The elephant
looks like a what? Maybe an anteater because of its snout. All right, look at these down here. It says, would these create a right triangle? What do we know about right triangles? How do we know it's a right triangle? A squared plus B squared equals C squared. And we're going to talk about this on the next page. What's important to know about the A, B, and the C? A and B are legs. Now, how do I know which ones are the legs compared to the hypotenuse? Hypotenuse is always the longest side, isn't it? So when I go to look at this, this would AB and this would be C. So we would have 9 squared plus 12 squared equals 15 squared. So if you do the algebra and the left is equal to the right, then yes, it's a right triangle. So you need to show this, show what you got out, and then yes or no. You would do that for all 3. Now, if it's a right triangle and they're whole numbers, we could go one step further and say it's a Pythagorean triple. This, no matter what, could never be a Pythagorean triple because they're not whole numbers. So it has to be a right triangle, and that's all we're looking for, right triangle or not. But to remind you, if it's a right triangle and whole numbers, it would also be considered a Pythagorean triple. Okay, if you flip it to the back, same reminder, of your a squared plus b squared equals c squared. This is your hypotenuse. So when you look at your triangles and you see the two legs, this is your A, this is your B, off of the 90-degree angle, what's opposite is always your hypotenuse. So here is your A, here's your B, here is your hypotenuse, the longest side. Okay, round to the nearest tenth. Make sure you follow those directions. And we have two more to look at. So stick with me, and then you'll have that time to work. Pythagorean theorem, they're telling us to use that to help us solve this problem. It says, draw a picture to help you. So picture is for points too. You have a rectangular swimming pool, so draw a big rectangle. And it has a length of 25 meters and a width of 12 meters. And it says, what is the distance from corner to corner? I'm going to draw from this corner to the other. Do you guys see that right triangle? So if you can focus on this, you see that we have a right triangle and we're really looking for C, the hypotenuse. Okay, last one, number 15. Let's take a read. Princess Fiona is locked in the tower. You volunteer to rescue her. The tower, here's my tower. It's got that little castle top. It's got big, tall, there we are. There's a water moat around it, and there's the princess in that window. See, that's a good tower, right? It does look like a rocket, but you know, it's my tower. There. And you can make little, bricks, and I don't have time for this. There, does that help? My artistry is astounding. Okay, so there's no entrance, and so you're going to put a ladder. Now, it says the ladder has to be 10 feet because there's a moat. That's why the water's there. So the ladder's going to be 10 feet away from the base. So here's my ladder. Do you see it? Coming up. So this is my ladder, and the tower's 36 feet high. Right here is 36 feet. So how long should my ladder be? Do you see that I'm trying to find the hypotenuse? It says to round to the nearest hundredth. How many decimal places is that? That's 2 decimal places. Fabulous.